Hello friends, in this video we will see questions from strength of materials or mechanics of materials. That is your second topic in your syllabus for AE Genco. In the given figure, he has given some figure. Let us assume that it is not given here. A stepped column carries loads. What will be the whatever the questions available? We will see them. What will be the maximum normal stress in the column B in the large diameter column if the ratio of P by A, that means load by area, has unity? Okay. So he says that it is P plus B by 1.5A. Okay. So that is the correct answer is C, 2 by 1.5. How much? Whatever you get. That is the correct answer. Okay. Right. Next. The stress which acts in the direction perpendicular to the area is called, this is your normal stress. Okay. So parallel to that is called shear stress and normal to the area is called normal stress. Number 3, which of these types of normal stresses, tensile and compressive stresses, tensile and thermal stresses, shear and bending stresses, compressive and plane stresses? The correct answer is A, tensile and compressive stresses. Actually, the normal stress is divided into tensile stress and compressive stress. Both. Compress will shorten the member, tensile stress will elongate the member. In a body loaded under the plane stress condition, what is the number of independent stress components? In 3 directions, x direction, y direction, z direction. That is 3. The correct answer is 3. If a bar of length, a large length, when held vertically and subject to a load at its lower end, its own weight produces additional stress. The maximum stresses will be at which section? At the lower section, at the built-in upper section, at the central section, or at every point in the bar? Actually, it will be at the built-in upper section, because the total load will be maximum load will be acting at the built-in upper section. That's why it will be having the maximum stress. Let us see the answer. Right. The stress in the stress is load per unit area, and after the addition of weight in the bar due to its loading on the lower end, the force will increase in the upper cross section, resulting in the maximum stress at the built-in upper section. Which of the following stress does not in a reinforcement bar is taken by the concrete? Concrete will take always the compressive stress. The correct answer is B. Sorry. Let us see the answer. Correct answer. Concrete has the property of taking good amount of compressive stress. So in the reinforcement bar, the compressive stress is taken by the concrete. A material has a Poisson's ratio mu is equal to 0.5. If a uniform pressure of 300 GPa, GPa means gigapascals, that means 10 to the power of 9 pascals. 1 pascal is equal to 1 Newton per meter square. 1 Newton per mm square is equal to 1 megapascal, and 1 kilonewton per mm square is equal to 1 gigapascal. So these are the standard formula, friends. So is applied to that material. What will be the volumetric strain of it? So we know that volumetric strain. So we know that we have a relationship between volumetric strain and the Poisson's ratio, etc. So substituting those values, I am going to get the answer is equal to 0 actually. Okay. Let us see the explanation. Here the value of mu is 0.5. So actually 1 minus 2 into 0.5. So that means is equal to 0. 2 into 0.5 be reduces to 1. 1 minus 1 is equal to 0. So volumetric strain results in 0. A diagram which shows the variation of the axial load for all sections of the pan of a beam is called bending moment diagram, or shear force diagram, or thrust diagram, or stress diagram. What is this? It is called stress diagram. Why? The stress diagram shows the variation of the axial load for all sections of the pan. The bending moment diagram shows the variation of moments in the beam. The shear force diagram shows the variation in the shear stress due to the loading in the beam. Next, the stress induced in a body when subjected to two equal and opposite forces which are acting tangentially across the resisting section, resulting in the shearing of the body. The body across its section is called bending stress, compressive stress, shear stress, or shear strain. It should be shear stress. Shear stress makes the body to shear off across the section. It is the tangential to the area over which it acts. The corresponding strain is the shear strain. What is the formula of a shear stress? Shear resistance by shear area, force by unit area, bending strain by area, shear stress by length. The correct answer is shear resistance by shear area. Resistance is nothing but the force. Which of the following stresses are associated with the tightening of a nut on a bolt? Crushing and shearing, In the threads, bending stress due to the bending of bolt, torsional shear stress due to the frictional resistance between the nut and the bolt. Select the correct answer using the codes given below. P and Q, P and R, only P, only R. Let us see the answer. Actually, bending stress only. Bending stress comes when there is some kind of eccentric load. Torsional stress will come when the nut is rotating. Shear stress will come in when tightening of a nut or bolt. So here the situation says that tightening of a nut on the bolt. So the correct answer is B, A. That means both B, P and Q. Crushing and shearing across the threads and bending stress due to the bending of the bolt. Both will be experienced. The transverse shear stress acting in a beam of rectangular cross section subjected to a transverse shear load is variable with maximum at the bottom of the beam, variable with maximum at the top of the beam, uniform, variable with maximum on neutral axis. So it will be neutral axis, the bending stress will be maximum. Let us see. Let us check once again, friends. Shear stress. Okay, so transverse shear stress is acting. So bending stress will be minimum at the neutral. What you call neutral point. But shear stress will be maximum at the neutral point. That's it's called neutral axis. Neutral axis. They will have the different nature, opposite nature. Bending stress will be least minimum at the neutral point, but whereas shear stress will be maximum at the neutral point. At the top fibers, the bending stress will be maximum, but at the top and bottom fibers, the shear stress will be minimum or zero. A block 100 mm into 100 mm and 10 mm height. What will the direct shear stress in the element when a tangential force of 10 kN is applied to the upper edge to a displacement of 1 mm relative to lower face? Let us see the answer. Correct answer B. Shear stress is equal to load by shear area. 10 kN is the shear force. Shear area is equal to that area, top view area, 100 mm into 100 mm. That means 10,000 by 10,000, 1 Newton per mm square or 1 megapascal. The correct answer is 1 megapascal, 1 Newton per mm square. Just now we have discussed. Okay, friends. In this video, we have seen some good questions from strength of materials or mechanics of material. In the next video, we are going to see some useful questions for your AE Genco from next topic in the syllabus. See you in the next video.